Bismillahirrahmanirrahim. Assalamu alaikum, dear friends. You are watching Study with Sheraz, and in today's lecture, we are going to talk about the decay constant. The decay constant is a very important quantity in the nuclear chemistry, and it's also known as the disintegration constant. So, let's suppose we have a substance A that is converting into the substance B, and at the start of the process, when time is equal to 0 second, it means that the process has not been started. Number of atoms of the substance A is n naught, and the number of atoms of the substance B is 0. It shows that there has happened no disintegration. Just we are going to start the process, and when the time is equal to t second, some of the atoms of the A has been converted into the B, and at that point the number of atoms of A substance is n, whereas the number of atoms of the substance B is n naught minus n. It means that whatever the atoms of A has been disintegrated or disappeared have converted into the atoms of the B. So after this time interval t, when n atoms of the substance A has been left, whereas n naught minus n has been decayed. If a small amount of A disintegrates into B in the time dt, then the rate of disintegration is minus dn over dt is directly proportional to n. You people have studied the kinetics, and in the context of kinetics, the rate of reaction is directly proportional to the amount of substance or the number of atoms of the substance. So dn is the small amount of change that has been occurred in the number of atoms of A. So dt is the small time in which dn is the change in the number of atoms of the substance A. So minus dn over dt is directly proportional to n, because we are left with the n number of atoms after time period t. So after that, if a reaction further happens, that is directly proportional to the number of atoms of n. So if we remove the proportionality and put a constant, so minus dn over dt is equal to kn. Here the significance of minus sign is that the number of atoms of A is decreasing, because these are continuously disintegrating into the B. So we have put the minus sign in order to show the decrease in the number of atoms of A. So here K is a proportionality constant, and this K is basically known as the decay constant or the radioactive disintegration constant. So if we rearrange this equation, minus dn over n is equal to k dt, and we put the condition in which dt is equal to 1 second, then this equation is modified into this expression, minus dn over n is equal to k. So on the basis of this equation, we can define the constant k. How we can define? In this manner, that decay constant is a fraction of total amount of radioactive substance that disintegrates in unit time, that is known as the decay constant. So decay constant is basically the number of atoms of this radioactive substance that decays in unit time. That is basically known as the decay constant of the radioactive substance. We can integrate this equation A within limits of the number of atoms and the time. So we have put the two limits, lower limit and upper limit of the number of atoms, and the lower limit and upper limit of the time period. So integral n naught n dn over n is equal to minus k dt, and here the limit of time is 0 and t. So if we solve the integral, so natural log n over n naught is equal to minus kt. So if you take anti-log of this equation is modified into this form. N over n naught is equal to e raised to power minus kt, and we can rearrange this equation by moving this n naught on the other side. So n is equal to n naught e raised to power minus kt. So this is the equation which shows the number of atoms left after the time period t. We can also modify this equation in another form by replacing the natural log with the logarithm or log 10. So minus 2.303 log n over n naught is equal to kT. We can remove this negative sign by inversing this expression n over n naught. If we take this with log, so 2.303 log n naught over n. So we have inversed this expression to solve this. Minus is equal to kT and t is equal to 2.303 over k log n naught over n. So this is another form of equation from which we can find out the time period required for a certain number of the disintegration of radioactive substance. So this was all about the radioactive decay constant. If you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.